Hello, I'm Mark Gleason. I'm a professor at Iowa State University, and I'm the leader of a 3-state project that is testing new systems for pest, disease, and weed control in organic cucurbit production. The title of the project is Resilient Systems for Sustainable Management of Cucurbit Crops. The funding comes from USDA NIFA's Organic Research and Extension Initiative, and also from the NCR SARE program. The project includes Iowa, Kentucky, and New York. It can be difficult for our organic growers to manage key pests like cucumber beetles and squash bugs. The cucumber beetles are bad enough on their own from direct feeding damage, but to make things worse, they also carry a bacterium that causes bacterial wilt on cucurbits, specifically melons and cucumbers and squash. Squash bugs are also terrible squash pests, and they carry a bacterium that causes another disease called cucurbit yellow vine disease, or CYVD. That's a disease that's increasing in importance in recent years. Our project is attacking this pest and disease complex from 2 different angles: an insect exclusion system called Mesotunnels and biological control. If these options show promise, we might be able to combine them for even greater effect. Mesotunnels are larger cousins of blow tunnels. We call them meso because they're somewhere in between an 18-inch tall low tunnel and a 16-foot tall high tunnel. Our mesotunnels are about 3.5 feet tall, and we cover 3-row plots with a single piece of fabric. Now, the fabric we use is another difference from low tunnels. Low tunnels use spun bond polypropylene fabric like Agribond or Rime. But mesotunnels use a nylon mesh material that is more like window screen, so air flows through it much more effectively than with the spun bond polypropylene. It won't overheat the plants even in midsummer. And the mesotunnels are large enough that they can stay on a cucurbit crop all season. Full season protection is a big advantage for the mesotunnels. In contrast, low tunnel protection usually ends when the crop starts to bloom, but then the plants are exposed for the rest of the season and pests and diseases can take them down. Organic insecticides are not very strong against cucumber beetles and squash bugs. But in mesotunnels, the nylon mesh is much more durable than the spun bond material, and we can leave it on, as I said, all season. Full season protection from mesotunnels can protect marketable yield and result in more consistent pack-out in organic cucurbit systems. But mesotunnels have their own challenges. One challenge is pollination. Cucurbit crops are dependent on bees, so how can we get the bees to the flowers without exposing them to pest insects as well? Another challenge we're working on is weed management. We'd like to keep the weeds down in the soil strips between black plastic rows. But how should we do that if the tunnels stay covered all season? For both pollination and weed control, we're looking at ways to open up the tunnels for a period during bloom, either the entire tunnel or the ends of the tunnel, so that bees can do their work and we can mow the weeds in the alleys between the rows. Biological control is another tool we're testing, mainly to suppress the bacterial diseases. We're trying out a wide range of proven biocontrol bacteria, as well as bacterial viruses called phages, to hold down bacterial wilt and CYBD. Right now, we're in the laboratory and the growth chamber, but the goal is to try out the best biocontrol candidates in field plots later in the season. We're also undertaking a socio-economic analysis. The mesotunnel and biocontrol strategies are new for organic cucurbits, so we'll need to find out when and where they can be profitable. This will mean economic analysis of the project's results under a range of projected production scenarios. Economics are critical, but even if the strategies show promise for profits, how will they fit into commercial organic cucurbit farms? We're doing on-farm trials in each of the 3 states, Iowa, Kentucky, and New York, to see how they can work in the real world of commercial organic farming. We're also surveying a range of organic growers throughout the project to get their feedback on what makes sense to them and what needs to be changed. We will use this feedback to keep our approaches as practical as we can. Another aspect of our project involves outreach to growers. We're using the whole toolbox of outreach tools to get connected to growers and stay connected. This includes the usual approaches like field days, along with blogs, podcasts, videos, and webinars. By the end of the project, we plan to put out a workbook about how these new strategies can fit into our organic cucurbit production in areas where these pests and diseases are major concerns. Thanks for listening. I hope you'll follow the progress of our project through all of our outreach channels. If you have comments or suggestions about the project, please send them to me or other project personnel. Thank you.